Hi, and welcome to MSc. In this video, we're going to be looking at naming ionic compounds with transition metals. So in order to start this out, we need to recall that transition metals can form multiple stable ions. That's what makes them unique and different than other elements in the periodic table. So when we name ionic compounds with transition metals in them, it requires an extra step. This is because the specific transition metal ion that's in the compound needs to be identified, because different stable ions of transition metals will form very different compounds with the same anion. So if it's copper 1 or copper 2, it matters in the compound. So if it's a copper plus 1 ion or if it's a copper plus 2, it will generate different chemicals. So here we have an example to work through. It's copper and it's nitrogen. We know that the metal, the cation, is a copper ion of some sort. And we know that the nitrogen ion is actually called nitride because it's the anion. But we can't just call this copper nitride because we need to identify, is it copper 1? Is it copper 2? So we need to figure that out. And so we have to place in the middle here a Roman numeral that goes in the brackets that identifies the specific copper ion that is involved in this compound. To do this, there's something called the zero-sum rule. And what this says is that all charges in the formula must equal 0. Well, I know that I have a copper ion and a nitride ion. I know that the sum of the 3 coppers and the 2 nitrides must equal 0. So that's what we're going to put out algebraically here. We're going to say that the 3 coppers, I'll call the charge on the copper X, plus the 2 nitrides, and we'll put the charge of the nitrides in brackets here, equals 0. Just to be clear, this 3 here led me to that 3 here. This 2 here led me to this 2 there. I don't know the charge on the copper, but I can look up and figure out the charge on the nitride. If you recall, nitrogen is in the 15th column. It's 3 away from stability, so it wants to gain 1, 2, 3 electrons to get that complete octet, which will make it a -3 charge. We'd write the ion N 3 negative, but as a charge, it will have a -3. And now, this is some algebra math to rearrange and solve for x. So 3 times x, there's nothing I can do with that quite yet. But I can say that 2 times -3 is -6, so I'm adding -6, which is the same as subtracting 6, equals 0. I can move this across the equal sign, make it positive, so 3x equals 6. And then, to finish this off, I can divide both sides by 3. And by doing that, I will get that x equals 6 divided by 3, which is 2. So what this means is that this isn't just copper nitride, this is copper 2 nitride. The charge on the copper must be 2 for this to work. We would rewrite this as copper 2 nitride, right? Filling in for that question mark with the 2 that we found. So sometimes you'll get good at this and be able to do this by inspection, but this is the formal way to figure out how this works. Let's try one more example. Here we have titanium. And titanium is a transition metal, and I know this because titanium is in this transition metal region. Transition metals are in this region of the periodic table with some exceptions. Zinc, for example, is an exception. It will always form the +2 ion. Transition metals also come out this way. For example, tin is a transition metal. So we have to be careful with this. As you learn more and more transition metals, you'll recognize them. So because titanium is a transition metal, I'm going to leave a spot in my name for the Roman numeral to go there. And I see that this is sulfur, so this will be the sulfide ion, which will make it sulfide, titanium something sulfide. I'm then going to apply my zero-sum rule. Here you see a subscript of 1, which we don't write. So I only have 1 titanium, and I don't know its charge. I'll put X. You can use any variable for that if you want to. I'm going to add to it the charges on the 2 sulfur. So the 2 goes here, and now I have to figure out the charge on this sulfide ion. Go back to the periodic table for this. Sulfur is group 16. It'll gain 2. It'll be a 2 negative ion, which is a negative 2 charge. And the whole thing has to equal 0. That's what the zero-sum rule says. Titanium is losing electrons. Sulfur is gaining them. So there's going to be no net charge on the whole thing. 1 times X is just X. And 2 times negative 2 is negative 4. So X minus 4 equals 0. X equals 4. Notice I didn't have to divide in this step because the subscript on the transition metal was 1. So that made my life a little easier here. So this is 4. The Roman numeral for 4 is 1 before 5. So IV. So this is titanium 4 sulfide. I hope this brief run through of naming with transition metals has been helpful. If it has, please like the video and subscribe to the station. And as always, thank you so much for listening and watching.